Woohoo! We're live. This is Math 60 Intermediate Algebra, and we're in the middle of graphing a bunch of parabolas. And I promised that the last parabola, this one, was going to be a little bit interesting and a little bit weird. We got Godzilla on hand just in case, you know, rawr. And so let's take a look at the parabola. Now, hopefully you noticed, even though this does follow this usual format, that we've done something really weird and swapped the x and the y. Normally the y is on the left and the x is the one that's getting squared. But this is the x is on the left and the y is the one getting squared, which tells me that we've either got one of these guys, a parabola that opens up to the right, with the axis of symmetry going through the middle in what you can see as a perfectly flat horizontal line, or it is a parabola opens to the left, again, with the horizontal axis of symmetry. So these type of parabolas are tipped on their side. And partly that feels very stressful, but the other half of it is we do all of the calculations exactly the same way. We just swap x and y. So for example, if I'm asked to put this in standard form, which I was, I'm going to go ahead and start Marie Kondoing this. So in other words, I'm going to take this 5 and put it over here because it is not sparking joy right now. I'm going to take 1/2 of -6 and get -3, and then I'm going to square that thing and get 9. And then, just like I did before, I'm going to, see, I'm thinking ahead. I'm using yellow before I write it in so there's less smeariness. I'm going to add in a 9. I'm going to subtract a 9. So the total of that is that I didn't ultimately change the equation. I'm just adding a 9 here and subtracting it over there. And this will allow me to see that, oh, that's a perfect square. So I've got y minus 3, the quantity squared, and then these two plus 5 minus 9 is -4. Now, here's the first weird thing. Remember that the vertex, this is called standard form or vertex form, is given in the form xy. We do not change the way we write x and y. We're still going to put the x as the horizontal axis and the y as the vertical axis. This is just, so we have to be thoughtful about what's happening. Inside here, this actually gives us the y value. The y value will be 3, and the x value will be -4. So we've reversed, if this were an x in here, this would be the x and that would be the y, but now we're switching. So how do you remember that? Well, the y is right next to the y minus 3 means that the y value is 3. And remember, in here, we're expecting that minus sign. So we get the opposite, positive. But on the outside, we get exactly what it is. So -4 goes to -4. Okay, so this is going to be a little weird because some things are going to be switched and some things are going to be the same. So we're just going to go through very calmly and just be, you know, if you show any fear, it'll just attack, right, Godzilla? Absolutely. So let's look for some intercepts. This is not bad. I can graph this. So intercepts. And remember that I have suggested that for the intercepts, this form, which is the standard form or vertex form, that's not really going to be your most helpful. I mean, you could use it, but it's not going to be very helpful. So if I have x equals y squared minus 6y plus 5, if I set y equal to 0, I get x equals 0 squared minus 6 times 0 plus 5. So x equals 5. So I get the point 5, 0. So far, so good? And then if I want x to be equal 0, I have 0 equals y squared minus 6x plus, 6y. My hand knew, my brain didn't. There you go. Oh, I almost fell for it. Y squared minus 6y plus 5. Now, you can either factor to solve this, or you can use the quadratic formula. I'm gonna hope that this is actually a pretty easy factoring problem in terms of either AC method or trial and error because it's just -5 and -1. So I'm hoping that one's not too bad. And then we get that y minus 5 equals 0 or y minus 1 equals 0. So y equals 5 or y equals 1. Now, this is going to feel weird because what's happening is we get one x value, which is going to correspond to two y's, which back in, I can't even remember what chapter we were talking about it, but when you first learned about functions, what did we say? You can't do that. So we're obviously not in function land. This is no longer a function in the traditional sense. Okay, so I've got 0, 5, and also 0, 1. So this is already a little goofy, but we have 4 points. I've got a vertex. I've got this one intercept. That's when y equals 0. So this is on the x-axis, and these two are on the y-axis. So, my numbers are all fairly small, so I'm going to go ahead and put my y-axis in the middle. Of course, as you can see, I'm using a ruler. Same thing with x, totally using a ruler. Always use a ruler. Rulers are important. If you don't use a ruler, the ruler factories go out of business, and then where will we be? No one will know how long anything is. People will talk about inchworms, but they'll just have to be worms. I mean, you will say, I need to put shoes on my feet, but people won't even have a word for it anymore. They'll like, I'll have to put shoes on my dangly things at the end of my legs. It'll be chaos, people. So buy your rulers, keep the ruler factories in business. This is important. Okay, so I've got a vertex at -4, 3. Now remember that we're still in x comma y land. We're still graphing it in the regular way. So x is -4 and y is 3. So 1, 2, 3, 4. There's -4. 2, 3. So my vertex is right there at -4, 3. And let's see, I've got an intercept at 5, 0. So 1, 2, 3, 4, 5. So I've got a point right there at 5. Then I've got two intercepts on the y-axis, one at 0, 1. There's 1, 1, 2, 3, 4, 5. One at 0, 5. Now, do you see the parabola? Can you kind of visualize it in your head? Remember that we've got a horizontal axis of symmetry. So our axis of symmetry isn't going this way anymore. It's going this way. This is the axis of, axis just means line, symmetry. And that is going to be given, since the horizontal line, it's going to be y equals, and what does y equal? Y equals 3. Okay, so it's a horizontal axis of symmetry, and we can still do symmetric stuff. So from the axis of symmetry, this goes down 1, 2, 3 to get here. So from the axis of symmetry, 1, 2, 3. We've got the mirror point right there. That'll help me graph. Remember that you should not make it pointy. Don't make it a triangle. Make it a round. So it's going to go around. I personally have a lot of trouble graphing these. They just, it just dawned on me. I know how I could graph it more easily. Bam. And suddenly my brain's like, oh yeah, I can totally graph this. I was just scared of the sidewaysness. Oh, I should have done this from the beginning. Wow. See, you guys are teaching me things. Okay. So it's weird, but there's our beautiful graph. This is a parabola that opens to the right. Here's our axis of symmetry. It's a horizontal line, not a vertical line. Okay, and I've got my vertex. I've got my intercepts clearly marked at 5 and at 1 and here at 5. And if you want to include the ordered pairs, that's great, or just make sure at least you've got the numbers written in. And I've got my arrows so that we don't fall into chaos. That's very important. And that's it. How you graph a sideways parabola. You guys are awesome. Woohoo.